Alright, welcome back everyone. I'm Chris Kugler, and we're going to be continuing our from our last part where we started putting together this very quick little indoor test level. We're going to be doing some finagling with our combat system, as well as a few other things, but I really need to start working on indoor levels, and I'm trying to learn how to use the Pro Builder tool to do that. So we put together this quick little thing last time, and now we're going to add some enemies. I think we're going to have them spawn in from somewhere in this corridor, and we're going to apply a quick patrol pattern, and we're going to have them patrol down and around here this side. So first things first, we need to bake our navigation mesh, so just navigation static, generate offlink, walkable, and bake. Sure. Let's see what happens. There we go. So our blue part represents our walking area, which seems to be fine. Yeah. Alright, so that's good. So that was one part done, quick and easy. Now we have our spawn point that is somewhere. Let's bring that up. Last time I was messing with my gizmos, I need to re-add a sphere collider. There we go. Obviously our radius is way too large. Let's bring that down to like 5. And let's pull this guy forward. Here, let's bring him in a little bit more, and we'll decrease this radius down to like a 3. Well, no, so this, so that's fine, right? Because spawn radius here, this guy, we want this to be like a 3, because 3 is going to bring us in to this range. We're not going to have them spawning outside of the bounds of the level or anything like that. Now, here's the tricky part, right? So previously we had this set up so that if our enemies walk outside of the spawn, they can't walk outside the spawn radius, first off, I think, as part of my grazing behavior. Secondarily, they become inactive unless the player is within this sphere, and that's more of an occlusion type of deal. So I guess because of that, we are actually going to make this a much larger radius. There we go. Yeah. Yeah, our radius gets much larger because of that. I think, you know what? We are going to change this. We're going to make this into a box collider. Box collider. And we're gonna finagle this a little bit, because I mean, quite frankly, it just that's a little imperformant for our uses. So let's see here. So center 0, X direction is gonna be like so. Z direction, we're gonna bring that over here. Z coordinate, pop this out like roughly that much. Yeah, that's fine. Our X coordinate, we'll see that increase as well. Whoa, easy there. Whoa, Nelly. Alright, so then we'll bring that a little bit larger. And we're also going to bring that in a little bit. So as long as the player is within these bounds, we're gonna be active. And there goes my trash trucks. Hopefully that's not picking up too badly on the microphone, but given how it sounded earlier, I sure bet it is. Alright, well, sorry about that. So I'm back now. My trash trucks decided to be jerks while I'm talking. Can't stand it. But let's get back to it. So yeah, so as long as the player's within this box collider, the enemies will be visible and also active, right? And the point of that was to not be wasting update cycles on enemies that are not perceivable to the player, whether because they're around a corner or something, or because they're in a completely different part of the area. But in our case here, we want a couple enemies to be coming around the corner, and they're going to approach, they're going to spot the enemy and approach, and the player needs to be able to avoid them. So let's take a look at what we have in the way of enemy behaviors, because I believe when I set up my prefabs for enemy AI, I did a few things. What did I do? Enemy units. I did a grazing enemy unit that stays within the bounds of the sphere. I did a stationary enemy unit that does not move, and I scrapped my patrolling enemy unit because I had done some changes to the way my enemies were loading up and switching AI states that kind of invalidated the more complex way I'd set up individual units. So let's take a look at what I had before. So I had this aggressive enemy type, and I think he did what? Well, he has a dead script on him, and that was probably the patrol behavior. I have a patrol enemy. Okay, wait, never mind. No, that's absolutely accurate. It's the exact same thing. So let's go to my scripts. So let's see if we can remember what the deal is. Enemy AI patrol behavior. Now, patrol behavior, it has a root, I believe, of a set of colliders, and each of those colliders is a point in the patrol pattern. And whenever it reaches a new collider, or rather an on-trigger enter, it goes and looks to see what the next patrol route in the path is. I believe that's how that works. Yeah, okay. So what do we need? A route transform, which we are going to set from elsewhere. New route. Who calls this? We have behavior manager, enemy movement behavior manager. What's a behavior manager? Controls the active state of some stuff. And it's got every single behavior, and enemy movement behavior manager. What the hell's the difference? Oh boy. This is why it's alright kids, this is why it's good to leave comments in your code, because I don't remember what my intended usage of these was. I mean, I know I had these here in order to switch state, but why do I have a regular behavior manager and then specifically an enemy movement behavior manager, which does not derive from the other class? I mean, what's the actual difference here? well, so honestly, I don't really care about this, right? What I care about is when's it calling new root. It's got a patrol parent. Patrol parent calls from patrol root.instance.transform. Find nearest child. Right, I remember how this is set up. I remember things, ladies and gentlemen. So, what we got here, we have a patrol root, and it's got a patrol transform within it. And that patrol has multiple sphere colliders that are set to be triggers within it. And that patrol root can have multiple patrol patterns underneath it. So it looks at its immediate children. Yeah, so we take the root's immediate children, find the nearest one to the position of the enemy, and that's the patrol that the enemy is a part of. And it from there uses this new root in order to choose the closest point in that patrol pattern that it's at, and sets that as our next destination. And from there, it just follows the route as necessary. So we need a way to execute this. So how about our patrol behavior? What do we got going on here? So I'm going to make a statement. And that statement is that just like our grazing behavior and just like our stationary behavior, I'm going to have a enemy unit type that is a patrol enemy. Now that patrol enemy is not going to switch AI states, just like these other ones stay within this AI state. It's going to be a patrol type enemy, and its patrol behavior is going to handle going around its patrol. But what else? But I do need a way for, once the enemy sees the player, to go and leave the patrol in pursuit of the player. Which is where things get a little more complicated. So let's take a look at our other AI states, because I believe I moved towards this more generalized composite AI pattern before. And these are both non-aggressive AI patterns, grazing and stationary. But I think if I have a patrol behavior, I inherently then also have some kind of a whatchamacallit, pursuit behavior, right? Or I think I called it chase behavior in my code. Which, what's this do? Yeah, it just sets the position to the player's position until such a time that it's within a certain distance, and it does nothing because the collision takes care of starting the battle. So that's kind of the deal. Can I just switch between these two? Like, is it okay for me to have the patrol behavior know about the chase behavior? And just tell it, hey, we're in chase mode now because the player's been seen? I mean, at that point, I am essentially having an enemy behavior manager. But the thing is, this was very much... I mean, what was this really doing? So we've got all these perceptor hooks and cancel state change invokes. So a perceptor was any set of triggers that would let the enemy know that the player was near. Like a proximity perceptor would tell it when the player is within X number of units, and then the enemy would recognize that the player was there. Or if there's a vision cone and the player intersects with that vision cone, then the enemy has seen it. Or rather, if it intersects with that cone, plus there not being any obstacles, an actual raycast can occur between the enemy and the player, then the player's been seen. Switch to chase phase. And this also incorporated the idea that the enemy unit... This was before I had the enemy unit concept, so the enemy unit was also the enemy, and it was responsible for switching to the battle phase. And I want to say I also have a search phase from one of my previous games that dealt with knowing the player's last perceived position and searching around that area and then rejoining a patrol pattern for another period of time that was near that last scene section before returning back to its original patrol pattern. And that was where it got a little more complicated. Like, it worked fine. It just felt like I was doing way too much in a fairly small segment of code. So now that I'm done rambling for a little bit, let's start simple. All right. So I think I do want this. I do want a manager of some sort to switch between patrols, or rather, to switch between patrolling and chasing. So let's go ahead and take our enemy unit. Let's create a new prefab. So we've got my grazing enemy unit, and we have a stationary enemy unit. And honestly, a stationary enemy unit just has no AI behavior because it just sits there and the player may or may not collide with it. Grazing enemy unit, however, the big thing is that these have these model placeholder distance perceptor. Is this even being used? Yeah, I don't think these are even being used. Like, what's the point of this? I don't even remember now. I mean, I know what the distance perceptor is, but I don't remember why I have this on my enemy unit. Like, is there a reason for that? I'll tell you what. Let's switch scenes. Let's go back and take a look, because I just went through this big refactoring push and cleaning up code and getting rid of stuff that wasn't necessarily being used. I definitely don't want to keep persisting things that aren't being used. So let's play, and let's take a look at our enemies. Spawn point, grazing enemy unit, distance perceptor. Yeah. I mean, honestly, I don't think that's being used. So let's take our spawn point, let's make him give me one enemy maximum. Let's play. Let's pause. And let's go ahead and deactivate this guy. So, yeah. So he's still behaving as normal. And we still triggered the battle as normal. Yeah. Yeah, I don't think that's doing anything for my grazing and stationary behavior. So let's go ahead and nix that. Enemy units. We'll get rid of that on both of these. Oops. Oops. I have to bring it in order to delete it. And once more, just to confirm things real quick. So this is the benefit of having a test level that you can use, right? Because, I just pop in here, I make some changes to my prefabs. Naturally, those prefab changes are going to apply to every other scene. But it's a nice way to kind of experiment and make sure things are working appropriately. That's where, like, if you played... like the recent Devil May Cry game, right? Devil May Cry DMC. They have that Bloody Arena, or whatever it's called, where it's just a survival mode, kill all the enemies type of deal, right? That was almost certainly their test arena when they were testing the enemy AI and the enemy collision and the combat and all that stuff, and they just turned it into a game mode. Like I would bet soup to nuts that that was the deal. That was just their test level that they used. You know, and why not, right? Because that's a perfectly fun mode. You know, survive horde mode, survive the death match. It's like, of course. You know, those are fun to play. It's challenging, but you also then get bang for your buck out of your, you know, your test bed. So let's so now we got that. So once again, our enemy prefabs. We're going to have a new enemy unit. So we're going to have a patrol enemy unit. And we're just going to go and bring one of him into the scene. Well, actually, having him in the scene doesn't really do much for us since there's no model or anything, but you know, we can still finagle a little bit. So our patrol enemy unit, we're going to add. So we have our patrol behavior. Let's pin this. We have our patrol behavior. We have our proximity perceptor. We'll worry about that in a minute. We have a chase behavior. So patrol behavior uses this. Chase behavior is fine. So I need some patrol points as well, right? So let's do that first, actually. So we'll give a, I want to say I have a prefab in here for that. Yeah. Yeah, so let's just bring this guy in. And we'll leave him here. And for our square route, there we go. So he's no longer going to be a square route, of course. So patrol point 1, we'll bring that here. Patrol point 2, we'll line this up. Patrol point 3, bring that in. Patrol point 4, we'll have him loop around. And patrol point 5 we'll have back here in this corner. So our enemies are going to come out of our monster closet, come over to this patrol point, come over to this patrol point, down here, loop back around the corners. And actually, because of the way our colliders work with the navigation mesh, I'm going to go ahead and make these a little further in from the columns. And we'll bring him a little further in, because the monster's collider is going to collide with this, and as soon as it hits the edge, it's going to detect that collision and switch to the new patrol point. So we want them to be a little bit offset from where we're actually imagining the enemy being. So that's fine. Now, our patrolling enemy unit, we will give him a patrol behavior. And what do we got here? Movement speed 10, turning speed 2. 10's probably way fast. Let's go to 5. No, we'll go to 3. Turning speed 5. We don't have any other parameters for patrol behavior. And, well, we'll start with that. So let's get rid of our grazing behavior. Remove this. Now when our patrol behavior initializes, well, it deals with this transition enter, transition exit stuff. Did our grazing behavior do that? Grazing behavior derives from AI behavior. It has transition enter. It has transition exit. But it doesn't actually use those, right? Like, that's kind of the trick. I was getting away from this transition enter, transition exit for my other behaviors because I didn't actually need them. But I was definitely hitting it. Was I? Because on enable calls transition enter, and on disable calls transition exit. So that's the deal. So for my patrol behavior on transition enter, if cur node is equal to null, then choose the closest node. Well, first off, choose closest node, I believe, relies on root transform. Yes? Yes. Use a little format. If this dot root transform is equal to null, then this dot root transform is equal to patrol root dot instance dot transform. Find nearest child to this dot transform dot position. Right? Leave ourselves a little note here if there's no root transform. So, problem is this is going to then immediately blow up, right? Like, this isn't going to work at all. There we go. Oh, I must have wrote this before I had that find nearest child extension method. Yeah. So we'll rename that. And look around. I feel like I made this a part of, yeah, I got this stop looking around and start looking around, right? Yeah, Looking coroutine, movement controller, dot look around. Yeah, so I swapped this up since the last time I saw this either. So on trigger enter, every time we reach our patrol point, we're going to determine what the next node that we need to go to is. And then we start looking around. And then once we're done looking around, no, wait. On trigger enter, if the collider we've collided with is not a child of our root transform, and if the index is not, yeah, okay. If our index, so yeah, so change our index for which node we're going to be going to. Next node is set to this thing. And then we swap next node for cur node. But why don't we just use cur node and just yield return? Code I wrote before I was really digging deep into coroutines. Right? So let's that's fine. We're gonna skip the look around part for the moment. And we're just gonna go straight to next target. And we'll let that just loop immediately, and we'll come back and re-up that look around once I've confirmed that this is actually working. So that's fine first off. Patrol behavior, our patrol enemy unit has that. Let's apply. We'll delete, and our spawn point is going to blah blah blah, enemies per unit, prefab dictionary. We're going to add another item. And this is going to be our patrol enemy unit. And as part of my refactoring, I've swapped some of this up so that our enemy information repository knows about the, it knew about the model before, but now it knows about the prefab it's going to use for the overworld and for in combat. So let's do this. So I want only patrol enemies. So let's move this down to one enemy type, Gray Bunny 1. And Gray Bunny 1 is going to use our patrol enemy unit. Yeah. Okay, so we'll be spawning patrol enemy units at that location. On enable, it should immediately pick up the nearest patrol via our patrol root object and start following it. So, what the hell? Let's see what happens. Any errors? No. What is going on with my movement here? Huh. Oh. No, those are all triggers. Let's disable them all and see if that's the problem. Nope, that's not the issue. Oh, whoops. No, I know exactly what the problem is. We created that, for our spawn point, we created the box collider. The box collider is an actual collider, it's not a trigger. Whoopsie daisy. There we go. Now, let's go off into our little corner back here. Scene. Well, there goes one enemy. No, he's just screwing around. Bunnies, you jack. Oh. Thought I'd, Oh, did I not, damn, I must not have applied the changes back to the prefab. Wow, okay. So that's a thing that happens sometimes. So let's do that. What did I say? It was 3-5? 3-5. We'll remove this and we'll go ahead and apply. Let's go ahead and actually double check that. Patrol behavior. Yeah. Alright. Let's also drop this down to 2 enemies. I don't need to keep track of that many. There we go. We'll move us back into this corner. Apparently I changed the wrong value. Whoops. So yeah, so there they all go. Yeah, hit that route. Get going, bunnies. Get it. Get that carrot. Go get it. Always a cool thing. You know, watch your AI actually act. So that looks like it's good. Oh, I think I changed this to 1 again because I'm dumb. So that's fine. But all right, so that's part 1 taken care of. What was the next thing we needed to do? So we got our patrol, we got our enemies following our patrol. When we spot the enemy, we need to, or rather when the enemy spots us, it needs to chase us. So to that end, let's add our chase behavior. Our chase behavior is going to start fight distance, and does it start the fight? What are those? Start fight distance. Okay, that's this thing. We're going to rely on our existing colliders for that. I mean, really... Yeah. I mean, really, that's the deal, isn't it? Uses perceptor data. I don't remember what that is. Active perceptor. I think that tells us the player's position, or not the player's position rather, but the perceived information, so that if the player's still moving, we're not just reading its inputs. But for now, I think we're not going to worry too much about it, right? So, And I've got this other behavior manager stuff and all this crap, but what did I do in here? So I have a lot of my older AI scripts that I kept in my project just so I can look at them and, you know, bring them in as needed. So my old behavior manager, my old behavior manager had this mechanism where I had string keyed variables that I could assign values to, true, false, numerical values for distance and things like that. And I had this evaluator system that would check all my conditions in the editor and determine if all the conditions passed, which AI behavior to use. And that was fine. It was, it's the kind of thing that I would want to make use of the ability to use the Mechanim style editor in Unity and actually build a proper tree structure with transition information. But then again, when I wrote that, Mechanim wasn't a thing. That was like a year and a half ago, or God, I don't even know when Mechanim came out. I don't remember when I did that either. That must have been, God, that was my first Unity project. I was doing a third-person action game. I actually got a decent ways into. I learned a lot, but it was just not... it wasn't coming out the way I wanted it to. So it was one of those things. Fail fast, and I mean, quite frankly, I spent like 3 months on it, and that was too long. I should have known after a month whether I was going to be capable of doing it or not. But let's see here. So, Perceptor. Yeah, how'd this work again? So the Perceptor is either triggered or it's not triggered, and it fires an event when it is triggered, and that might depend on the type of Perceptor, right? So this was the base class, and I had for instance, Proximity Perceptor, and the Proximity had a trigger enter on it for a collider, and that collider would take the information of where the collision occurred and set the trigger to true. And on trigger exit would reset the trigger after a certain amount of time. The behavior manager would make use of those perceptors. Yeah, it would know the perceptors that were attached to that enemy unit, and it would check to see if any of them were triggered. And if any of them were triggered, it would determine if that trigger, based on its priority and the information that was being held, would require a AI state change. So, for instance, we were talking about proximity earlier. That might, if a patrolling enemy had a proximity alert because the player was moving too close to it, that would trigger the chase behavior, and the enemy would then pursue the player. So what? Do I want to use that type of thing? I think I do. I want to use a similar mechanism at least. So perceptors and all this crap should be in my... Oh, it is. Okay, I brought this over into my new scripts. That's interesting. I wasn't using them to my knowledge, unless it was way early in my process. So let's go ahead and make use of this, because I do have backups of all this stuff. So our patrolling enemy, he isn't going to have a... I have a vision cone perceptor, yes? Yes. I believe I have an old prefab for that as well. Or not. Yeah, I don't. He has a sphere collider on him. Why has it got a sphere collider? It's literally just tracking radius. So that's dumb. That's stupid. Let's get rid of that. Get rid of this. Serialized field. Private float. View radius. View distance. Raycast. We're going to do this view distance. And that takes care of that. Direction to player, angle to player, hit info, field of view, 110 degrees. Yeah, that sounds about right. So what are we doing here? Oh, that's why I needed the collider. Because we're using the on-trigger state to determine if the player's within range. Yeah, okay. Chris, you need to pay more attention. Read the code before you make changes. Alright, so sphere collider, when it's on trigger, if the player's within the range of the collider, our tag is equal to player. We take the direction to the player, and from that we get the angle between the enemy and the enemy's forward and the player, right? So, let's see here. Hang on, bear with me, folks. I'm grabbing my drawing pad. Let's plug this in. Let's flip the USB port over and then plug that in. Yeah, it's the wonderful thing about USB, right? You always put it in wrong the first time. So let's take a new page. So let's bring this in here. So yeah, so the general idea, we're gonna have so we got our player and we got our enemy, right? So enemy is looking, actually, there we go. Takes a few tries. Let's change color. So our enemy is looking forward, right? And he has or rather we have a direction vector so we have a direction vector v1 that is going between the enemy and the player, right? And we have our vector 2 that is the enemy's forward vector. So we know that if the player is within range, that the angle, that if the enemy has a vision cone, right? So vision cone would look something like this, right? So he's got a forward direction, and we're saying within 110 degrees field of view, that's going to be a 55 degree field of view on either side of his forward direction, right? So 55 makes this angle 110 degrees, right? Forgive my drawing. If the player falls within, if the angle between the player's forward, God, I'm running out of colors, people. We're running out of colors. Yeah. So if the boy, this is getting messy. This is hard to do, you know, using a bamboo thing, these touchpads, like having the disassociation between what you're actually drawing and what's on the screen. It's a little tricky. So if the angle between this vector and this vector is less than 55 degrees, then we know that the player is within the vision cone, right? Like, that's kind of the deal. Hopefully that makes sense, because I do not want to draw that again. But that is the general idea of what we're talking about here. So, to get back to it, we've got our field of view degrees and our angle. And if the angle to the player is less than that, and we know that we're in range because we're within range of the collider, then we need to do a raycast. And we need to do the raycast to determine if we have a line of sight to the player. There's no other obstacles obstructing us, like these pillars, for instance. if that collision, if that raycast hit collider is with the player, then we know that the player's position is that position, and we know that the trigger needs to be set to true. If any of these steps fail, our trigger is false. Similarly with our on-trigger exit of the player's gone out of range, then we are immediately not triggered. So, how do we want to make use of this? I'm thinking that I want to just fold the idea of my behavior management into my patrol behavior. I think that's the deal, right? Because ultimately we're patrolling for the reason of finding an enemy, right? That's the purpose of having a patrol. If we are just talking about creating a pathing AI that doesn't care about the player, right? Like it's just an autonomous thing in the scene. Let's think about that for a second. So what other uses other than enemies will we have a patrol behavior, right? If we need any kind of way for an actor in the scene to follow a path, whether they interact with the player or not, that's a scenario where a patrol behavior would be in play. Right? Maybe we have some birds in the air and they're going to fly, they're going to circle an area, right? We want them to just, hang out in that one section, but we don't want them to go too far, and they're just going to fly around every so often in a fixed pattern. What else? Maybe NPCs do that. NPCs don't need to chase down the player, but maybe they have a fixed route through the area that they're going to follow. So in that case, we're going to... Well, that's easy. So I've got my patrol behavior. We're going to have a chase behavior as a member. And chase behavior is going to be optional. If the actor doesn't have a chase behavior on it, then it can't change state transitions. Easy peasy, lemon squeezy. And by that same reasoning, though, alright, so you know what? We're going to subclass. Did I just turn caps on? I sure did. Alright, so we got our patrol behavior. We're going to make these... Yeah. Transition enter, transition exit. Well, hang on. So on trigger enter, on trigger exit. What other things do I have that I can override? When we're updating our movement. Yeah. Okay, so that's fine. So for patrol behavior, we're saying that when we enter, we're going to find our transition and we're going to start a patrol. At some point, we need to stop patrolling, right? So we're going to be overriding our position with the movement controller, as well as we need to prevent this on-trigger enter from triggering us to move to the next node if we're in pursuit. Am I overcomplicating this? So we're going to know about private void in pursuit, private bool, if not this dot in pursuit, then that. So we're only going to allow our trigger enter calls to bubble up to our normal behavior if we're not in pursuit. Second, we need to detect if the player has been seen by a perceptor, which means we need that perceptor stuff from our behavior manager, right? So we got this perceptors list, and we have find perceptors in hierarchy, which does what? Get components and children with perceptor. That's pretty much all it does, and it hooks and unhooks the events. Do I want to use the events, or do I just want to loop over and check every frame, or rather at an invoke repeating period? I think the invoke repeating period is more realistic. It gives the player more of a fair chance than them just immediately responding to the visual cone perceptor or something like that. I can do the invoke repeating. Yeah, actually, that's more realistic. And the invoke repeating is just going to be on like a half a second interval or 1 second or something like that, like half a second. So if the player accidentally goes into the vision cone and backs out real quick, there's a chance they just weren't spotted. So I like that. I like that a lot. So enemy patrol behavior, he's going to know about perceptor array. Start or awake or anything. It's not virtual, but it should be. So patrol behavior, start. Where'd we go? Yeah. Well, like I said, I'm not grabbing the events. We're just finding all the perceptors. And that returns a perceptor array. Yeah, okay. So in our update, and I'm not using update in the patrol behavior, am I? No. In update, not an update. No, we said we were going to invoke repeating check perceptors. Invoke in time seconds. Repeats every, yeah, so we're going to start, we'll we'll start a few seconds after the enemy becomes active, and we'll repeat every 0.5 seconds. So if we are triggered, then in pursuit is equal to true, return in pursuit is false. If we're already in pursuit, we're not going to check. No, you know what? We don't need to do that. We can this dot cancel invoke check receptors. Yeah. And we want, so I don't know if this exits immediately from the function or not. I'm not sure on that. And in that case, we are also then going to invoke repeating check pursuit timeout 3 and 3. We'll check that every 3 seconds. Now, what this is going to do very similar thing. Actually, you know what? I forgot. I'm not planning on doing an iOS. Since this is going to be a PC title and not an iOS one, I can use link, though that might be an issue when it comes to Mac. I'm not 100% sure. I just know that the runtime for iPhone hates link. It freaks out every time it needs to do any kind of reflection-based setup or anonymous types or any whatever the bullshit is with that. But that's fine. I'm using link in other places, so I don't mind just doing it. Next dot is triggered. So if all of our preceptors are not triggered, then this dot in pursuit is false. Invoke repeating check receptors. This dot cancel invoke. So we'll flip our invokes, and that's fine. So check all preceptors. So the inverse of that, really. So if any of them are triggered, we're in pursuit. Invoke repeating is going to be set for checking our pursuit timeout every 3 seconds, starting in 3 seconds, and we're no longer checking preceptors. Now, our check pursuit timeout, if all of them are not triggered anymore, the player's no longer in the vision cone or whatever, and it's been at least 3 seconds, right? Then we're no longer in pursuit. We're going to invoke repeating, check preceptors, and we're going to cancel our invoke, right? So here's the trick though, right? So we're saying that within 3 seconds, if the player is no longer within the vision cone, we're giving up. That is incredibly shallow, right? So yeah, we'll leave it there for test. We're probably going to bump the time on this for, a bit later. We'll leave them in pursuit for like 5 seconds or something like that. And then we'll also need to make sure that before we go and switch back to our previous pattern, which we'll also switch to our patrol pattern in a few seconds here, we need to make sure that they're out of perception for a certain amount of time, right? Not just that they're out of perception, but we'll come back to that in a few. So just to finalize this out, we need to restore our patrol pattern, right? So as this stands, well, first off, if any of our perceptors are triggered, then we're in pursuit. Check pursuit timeout's going to start executing every couple seconds. But we're also going to update, right? So private void update if this dot in pursuit, this dot target position is equal to player dot instance dot transform dot position. AI behavior has an update that it does. What is its update? Its update does nothing, so we'll go ahead and just override it anyways. And for future proofing, base.update as usual. So I want to say that target position update requires a little bit more, right? Update movement controller. Do I still do that in my grazing behavior as well? Sure do. Now, patrol behavior, I have this set next target, right? What else am I doing here with target position? Is that it? I want to call this from the child. So we're going to return us back to the closest node in our original patrol, right? So if we're no longer in pursuit, that's fine. Okay. I think we're good. I think we're good on this part. So we're an hour in, minus the part I'm going to cut because my garbage man is a jerk. So let's go and stop this here. And in our next session, we're going to go ahead and wire this up to our prefab and test and make sure it works. So thank you for watching, and I will catch you next time. Take care.